All right, so this is Casey Davis and Blaine Backman, and we're going to showcase the results of our search lab, both for A-star and for RRT. We're going to do that on two mazes, so this is the first maze, and we'll run it through both algorithms, but just to give you an overview here, um, we see that we have some misleading turns that it has to go around. We see this interesting place where it has to make a choice about whether to go above or below towards the goal. And so we'll run this through both algorithms and see how it performs. Okay, this is the A-star algorithm's performance on that maze we just showed you. Um, we went ahead and drew the path so that you can see where it's trying to go, and this is a very distinctive A-star path. It's kind of blocky. And we see that we follow it pretty well, and we get all the way towards the goal. This is the RRT version of our algorithm for that same thing. So we can see that it is prone to meander a little bit more, but it's less blocky in the way that it goes around obstacles. So it goes, for instance, around the outside of this wall because it's just branching around looking for ways through. So we can see that it does pretty well here, and once again makes it to the goal. This is the modified version of RRT, where we went the entire distance towards our random points. We see that it makes more straight lines, which is kind of nice. It tends to meander a little bit less in the short term, although it goes a little bit more out of its way in the long term. And there it makes the goal. This is an overview of the second maze that we did. We didn't have another group to get a maze from, so we settled for making another one that we felt was pretty complicated. Okay, this is our second maze, and this is the A-star algorithm being run on it. So you can see kind of the grid-like feel of the A-star algorithm, and you can see that it finds the path. It doesn't go up this box canyon, and it manages to circle all around like it needs to do. So this is a successful run of our A-star algorithm. And there it is. Okay, so this is our RRT algorithm on the second maze. We can see the path that it's made here. So these paths are the lower, smaller blocks, and it was able to handle the maze pretty well. It didn't have any real problems with it. The only thing is that it took a while to search the space because RT is a little bit random, and so it required a lot of nodes, which took a lot of time. But we can see that it does pretty well. There's a path going all the way to the goal, and our ball does a pretty good job of following it. And there we are at our goal. So this is the modified version of RRT, and once again you can see the distinctive straight line nature of this algorithm. Some of the downsides to it is there you can see it gets closer to the edge, and as we mentioned in the earlier test on the other maze, it'll sometimes go a little bit more out of its way. But the nice thing about it is that it tends to, when you're covering a long distance, be able to go a little bit faster and with less iterations. So we see along here, and just this maze in general requires our spheroid to go a really long ways, and RRT can be really slow, and this just speeds it up a little bit. So we liked this mostly because it was just a little bit faster to initialize the path. And there it makes it. So this has been Blaine and Casey. These are both of our mazes and all of our algorithms on both of our mazes. And we see that they've done pretty well and that they reach the goal like they're supposed to.